Help for on OL work 1.2. Let's see. I'm not going to do this. There's another one on problem 5, and you've done some already. If you're having trouble, come and see me. Problem 2, I want to know, this is a yes or no question. So you get to, the final answer has to be yes or no. Yes, they are inverses, or no, they aren't. And you have to show why. You don't get to just guess. Okay, so okay, F is supposed to undo what G does, and G is supposed to undo what F does. So your answer is yes, they are. If you plug in X originally, you eventually show that you're getting X back out. So what is, let's see, F circle G of X, otherwise known as F of G of X. Get used to the circle notation. So we're plugging G into F. So we have F of thingy is cube root of, let's say, 3 thingy. This is why I suggest the empty parentheses, is so that you can, also, G is really long, so empty parentheses so that you can make sure you don't lose anything. Okay, so F of G is going to be, let's see, just going to write it down again and then fill G in. Okay, so what's the first thing we're going to do in simplifying it? Get rid of the extra parentheses. I need to distribute the 3, not just to the first term, but also to the 1. Make sure you do it. You have to do your simplifying in order. You can't just say, okay, clump, 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 it's X. No, you have to show the steps. So when I distribute the 3 and the 1/3 cancel. The 4 has to stay outside the parentheses. Now what? The 3 and the -3 cancel. So I just have x minus 4 cubed under the cube root sign. Oh, under the cube root sign. Yay, so far so good. And then we have to do G of f of x. So G, I'm just making sure that you recognize the notation. You're sticking F inside. So we set up the template for G. G of thingy, let's see, is 1/3. Where is it? Well, you've got it on your page, and I've got it on my page. Thingy minus 4 cubed plus 1. And I'm plugging F in. I'm just going to write on top of it this time. Let's see, what is F? Cube root of 3x minus 3 plus 4. What's the first thing we're allowed to do? Again, the inside parentheses, we can cancel the 4 and the negative 4. No, you can't cancel the cube root first, because the 4 and the negative 4 aren't cube rooted. So you have to turn it into just a cube root before you can cancel the cube and the cube root. Order is important. Okay, so I'm canceling the 4 and the negative 4. And so then I just have this. Oops. Now I can cancel the cube and the cube root. And then the 1/3 and the 3, the 1/3 can get distributed to both terms. So you have x minus 1 plus 1. It is x. That's not the answer. Remember, the answer now, be careful, we will screw up the order, and then they won't be inverses. And if you don't pay attention to the order of operations, you will answer wrong. You may think it's a inverse, and it's not. So be careful with this. Okay. There's one of these that is, well, there's two of these that are hard to invert. One is, so these two functions are not one-to-one, so they will be hard to just invert. This pen is acting weird. Well, okay. H inverse of 5, that's not too bad. For the inverse, you remember that the inverse input is the original output. So we're going to take h of what equals 5, right? So we say 3x plus 2 equals 5. Solve. Lovely. F inverse of negative 7. That was a terrible absolute value sign. My ones and my absolute value signs are hard to tell apart. Okay, add 1. There's two numbers whose absolute value is 6. This is where you have to split it up. Just like with squaring, x plus 2 is plus or minus 6. Okay, so we can get two values when you have something that's not a function. F of g of h of 1, we need to figure out h of 1. Let's see, h is 3x plus 2. Then we have to figure out g of 5. 25 plus 15 is 40. So we're looking at f of 40. Incidentally, with absolute values, make sure you're not trying to simplify by killing off individual minus signs inside the absolute value sign. So just a warning. the absolute value of x minus 3 is not x plus 3, or you can't turn a subtraction into an addition by using absolute values. You can only make it a subtraction the other way around. Okay, so g of f. It's easier to tell what you do first. We need f of 2. So negative 3 minus 1 is negative 4. Wait. Oh, that's 2 plus 2. Negative 5. Okay, so notice that squaring does switch the sign, but you got to be careful with this one. Okay, h of f of x. 3 hoohickey plus 2. Can distribute the 3 and combine these two constant terms. But that's basically all you can do. This pen is skipping along. Sorry, I'll get another pen. Don't want to stop the video though. Okay, f of g, we're sticking g inside. Again, negative absolute value of hoohickey plus 2 minus 1, plugging in x squared plus 3x. Okay, and again, a lot of the time the extra parentheses are not necessary, but I like to fill it in that way. That way you don't drop things. Okay, that's it. All right, are these invertible? So we take a look. What we're going to do is we're going to graph to check. Okay, so if you graph this, this thing fails the horizontal line test. We need to restrict the domain to just half of the parabola. We've already talked about this a little bit, but we want to have just half a sideways parabola when we take the inverse. So let me write this down. I'm not going to say this. What it does is basically on the inverse side, instead of taking the just square root, you take plus or minus the square root. You can't do that. That's not a function. So how do you find the right side of the parabola? The vertex, let me just remind you again. for the first time in a while. The x-coordinate is negative b over 2a, which is what we want. So we have negative opposite of, let's see, what's b? 8. 2 times negative 1. So this is 4. So okay. Next, if you graph this one, no, this one's it flattens out, but it doesn't actually go back up again. So there's only one place where it's flat. This one does pass the horizontal line test. Let me see, R1 to 1. Gosh, this doesn't want little stops. Here, let me erase instead. Okay. Okay, so just as a warning, you can't just say, because it's a cubic, it has odd degree. No. Okay. So we're going to graph these functions to see. This one, it needs to be restrict. Because it fails the horizontal line test. Oops. Okay, so incidentally, absolute value form for these linear absolute values is very much similar to vertex form in a quadratic. It gives you the value where you turn around. Okay, that's the one number that only has a single absolute value, has a single value that has it for an absolute value, is 0. Everybody else has matching pairs. So we take the part inside the absolute value. Okay. So that's going to be x equals 3. To points greater than or equal to 3. This one, lines, all lines pass the horizontal line test, except horizontal lines themselves. So constant functions, no. But, so we will see that in the problem below, but there's no restrictions necessary. What about this one? If you graph this, again, the domain excludes the place where the denominator goes to 0. So if you graph this on your calculator or on Desmos, you see that, oh, by George, it starts to look like that. Rational functions that are ratios of two linear functions always pass the horizontal line test. So okay, t of x equals 4, constant functions grotesquely fail. So okay, so any number will do as a restriction. So if we say that's just pretty random, isn't it? Yeah, you can restrict it to anything. Again. Oh, I already said for example. Okay. So one thing about domain of and range of a function and its inverse, as long as they have been restricted, okay, so then we've the domain of the function and the range of the inverse are the same as long as the function's original domain has been restricted. So let me just show you what I'm talking about. Okay, so if I have x and f inverse, well, that with a table it's really easy. What do? You just switch what's in and what's out, right? We'll talk a little bit about what happens if the original function is not one-to-one. So like there's duplicated outputs in the original. Then we would have a little bit of problems. Let's think about that eventually. Okay, what's the domain of this? It's individual numbers. I'm going to be lazy and not write x such that x equals. That's just math secretary shorthand anyways. Okay, so this is a useful little factoid, but you do have to be careful with functions that aren't one-to-one. So for instance here, if I look at x plus 3, the domain is all reals, and the range is just the numbers bigger than 3. Why didn't the 3 come out? Let's just calculate the inverse. So how do you find an inverse again? Let's calculate G inverse. You switch the letters, x equals y squared plus 3. Solve for the new y. So let's pick one. We'll say G inverse is just the positive square root of x minus 3. And then what's the domain? It's x greater than or equal to 3. That matches with the range of the other. But what about the range? Oops, sorry. I like to color code these things. I know it's probably just me that cares. Square roots can only be greater than or equal to 0. If I look at this graph, it just does this, and it only goes up from a height of 0. So we had to restrict the domain of the original function is the same basically as restricting the inverse to being a function. So we want to be cutting down the domain of G to the right side. Okay, this one, the vertex is obviously on the y-axis, so I'm not going to bother to do the negative b over 2a thing. Okay, I want to talk about this one, because these are interesting. These are one-to-one functions, I said on the previous thing. So let me just write that down again. Ratios. That's a terrible N. Okay. Okay, so let's just do this. I'm going to find H inverse first and then do a comparison. Okay, what are we doing? We're moving the y terms together. So I need to move this x over and I need to move the 2y over. So I have okay. Positive, x turns positive, 2y turns negative, factor out the y, and solve for it. Okay, so it's actually easier to find the range if you look at the inverse function in these cases. Oops, so sorry. I started saying range and then I wrote the range. Okay, the domain is easy. When does the denominator equal 0? X at x equals 1/3. When does this one equal 0? When 3x minus 2 is 0, 3x is 2, x is 2/3, and we want to chuck that out. So the whole is at 2/3. The domain does not include 2/3. Be careful. All right. Yeah, watch for the difference between not equals and equals. It depends on what question I ask. So the easy way to do range is to just switch. The range of the original is, you use letter Y. And switch. Okay, so for example, if you cross multiply this, you get 6x minus 2 equals 6x, and you get negative 2 equals 0. Well, that's not true. All right, let's look at this one. What's the domain? Oops, I really like making them proper colors. So comments in blue and actual answers in red. Domain, let's see, starts at negative 2, goes to 1 but gets filled in, so that's fine, and then gets all the way to 5. So range going up from the bottom gets down to negative 6, and then gets up to negative 2, but then there is a gap. Let's say the top is at a height of 5, and there's no equal sign there. So, yeah. Okay, so how do you graph the inverse? Basically, by far the easiest way is just plot points. Let's see. This pole is at 1, 5, so the inverse will have at 5, 1. Okay, this point is negative 2, negative 1. So the inverse goes through negative 1, negative 2. Sorry, negative 1, negative 2. And it has a little line segment that continues between them, so that's also going to be a little line segment. Notice it'll also cross the x-axis at 3, just like the original crossed the y-axis at 3. Okay, and ditto. Let's see. So negative 2, 1, and then, so 5, negative 6. Oops, I didn't make my thingy big enough. Oh well. Negative 6, 5. I'll fake it. There's my inverse function. And is the original function 1 to 1? Sure enough, this function goes from -6 to -2, has a little horizontal gap this time. Oh, why did I write y? Because the original had a y. You do have to switch the letters x and y. Okay, so the domain and range will not be immediately, switchable, but you can still look at the picture and figure out the domain and range.